Good morning. Good morning, Mr. Tyler. You're on mute. My first. Oh,
Hold on, Dominic, 1 second.
you're fine.
Okay, what were you saying, sir?
Nothing. Just wanted to verify I was here.
Oh, okay. All right. You might want to get your screen set up. We're about to start in a moment.
All right.
Oh, you left. Oops. Turn that off. All right. So I guess I give everybody 5 more minutes. It's 12:20. So let's see here. Just make sure everything's working. I think it's working. There it goes. Okay. I'm like, why is the volume level down? Okay. Get that fixed. Just put 5 minutes. They're gonna come in. Get these things set. I should turn down the music. There we go. Where's my attendance bar at? There we go. Welcome class to me. Okay.
And
We're about to begin in a moment though, because it's like 5 minutes after. You got your screen set up and everything?
no.
All right, you might want to do that real quick. Let me turn this off. Okay. What's going on with your camera? You gotta turn it on, young lady. All right, let me move this out the way. Should have her screen set up. Oh, she rolled her eyes at me. All right, come on. So yesterday we worked on work and we're doing. Let me do this attendance again. Dominic didn't come back. Let's see here. He came early and just didn't come back. Garcia, so I gotta mark him absent. All right. Oh, turn this off. Okay, Tamia's here. I guess everybody else gonna pile in when they get here. Okay, let's share this to office. Now today is a sync day. I think it's an async day. I was trying to look that up. Did you get the asynchronous schedule for what days are office hours for teachers or no? Tamia?
Oh,
No?
no.
Oh, okay. I gotta find that and send it to you guys again. All right, so it's my understanding asynchronous days are like office hours, and this is engineering. So you guys' days are on Thursdays. Obviously, I gotta remind students of this because nobody's coming to those days. All right. At any rate, let's get into the norms, and then we're gonna talk about today's problem. Where are the norms at? These are the norms right here. All right. Oh, I made it too big. So Tamia, can you read the 5 norms there? I need to bring it down to 150. Can
I
you
don't
see all
feel
of
like.
them? You, you said what, Tamia?
I don't feel like.
It's presented on the screen. Do you see it now?
I said I
Look
don't
what
feel like.
you say you don't see it? Okay.
I said I don't feel like.
You don't feel like it. Well, why not? What's
No.
going on? All right, I'll follow up later. Stevenson, can you read the 5 norms there? The basic norms. All right. Take notes. Stevenson, can you hear me? No? All right. For some reason, you're still muted, I guess. All right, so I'll go through them. No one has a right to hurt another person. Education and the classroom are sacred. We will never behave in a way to discredit ourselves, our school, or our family. An Excel Academy and Southwest student, I hope you will always act like a lady or gentleman. We take pride in Excel Academy and Southwest. The 5 academic norms. Mr. Stevenson, are you present?
You respect the opinions of others.
Oh, that's David. Okay. You okay? Can you read the rest though, David? That's pretty good. I
Yeah.
heard you. Let me turn this up.
We respect the opinions of others. We respect the culture of the classroom. We are attentive to participate.
Okay.
We have high expectations of ourselves, our peers, and our teachers. We are here to focus on preparing us for post-secondary endeavor.
Thank you, sir. All right. So let's keep going. Where we at? So physics, right? No, we're in engineering. Sorry about that. This is a third period. Yeah. Here we go. And then, hello, Castro. I gotta go back and do attendance. I see. I knew they was gonna start doing this. That's why I was trying to take my time through this. Where are we at? So you should have SB open, and you should also have your Gmail open, right? And open up. See here. And what we're going to do is we're going to take a look at, what today's assignment is. So I'm going to come around and see who's willing to participate today. I'm gonna go down a list because I already do attendance too. Let me go chat. All right, let's put that in there. All right, this is for participation points. Stevenson, are you back? If not, I'm gonna come to, and David, you got points for that, so thank you, sir. But Stevenson, did you come back yet? Because you didn't respond.
We gotta copy that down.
Whoa, you got an echo. Huh? I'm sorry, what, Stevenson?
Is it working?
You said it's not working?
Is it working?
Huh?
Can you hear me?
Barely. Oh, ooh-wee. All right.
All right, you hear me now?
Yeah, you're better now.
All right, now what we was reading?
I just wanted you to read what's in the chat, Stevenson. Can you do that?
Which S? My S or S?
In the chat it says hello. Do you see that?
Hello, future.
There you go.
Is engineers.
You don't see the rest? Oh, okay. I guess not. All right. Castro, can you read the rest there? Oh, hey, Irvin. What's going on?
Hey, Mr. Tyler. Can I take Tamia to finish her STAR test?
Yeah, sure. Of course. Yeah, go right ahead. Thanks for letting me know you guys are doing that. Yeah. Tamia, you got to check the chat. Let me turn the chat on. I'm sorry. So that you can send it there, and then she could take it from there and go, I guess.
Okay.
I don't want to take that stupid test.
Okay, yeah. She also told me what she don't want to do in class. So please take her with you and talk to her about what she feels and what she needs to do.
Tamia, can you jump on that link, please? Thank you.
Okay. Thank you, sir.
We gotta write that down in the Google
right.
Docs.
You said I got to go to Google what Docs, David? What did you say?
You want us to write that in the Google Docs?
Yeah, we're going to put the questionnaire.
All right.
So
You're muted.
I'm muted. Can you hear me now?
Yeah.
Okay. So no, very good. Thank you for that. Now you're gonna, like you said, go to the Docs.
Hey, I'm sorry. I like that. I'm sorry.
And you back, Stevenson? Okay.
Yes.
I see you there. Okay. So as you were saying, David, you're gonna put in there the document title is due now, right? And today's document is the 17th of November, and this will be 2020. Okay. So header, to show you what that is, you put your name. I'm putting my name, but you put your name there, right? Next, you're gonna put the date again. So it's the 17th, and this is still November of 2020. Period is third period, right? And this is called Intro to Engineering with Robotics. Go into the robotics part when we go out to specialize in certain curriculums. That's how I'm thinking to roll that out to you guys. Oh, okay. I see Garcia's come back. I got to do attendance again. Some more faces. Castro, what's going on with your camera there? You guys got to follow the rules. They're watching. All right. So we got Castro, I think, is present. Kathy is not present. David's been here. Garcia just came back. Jones, I see, is here. Tamia is with Mr. Irvin. Richardson is absent. Daniello is absent. Stevenson, that's who I missed. Here we go. He's been present. Terry, Melody, I do not see in the list. Okay. And no Mark Weber. All right. So that's the attendance so far. Let me save it again. I'm trying to get this log correctly, everyone, because then you guys got so many days that you miss, and then it's a problem. It's hard to get a grade. So keep that in mind. I'm trying to wait for Esby to look. There it goes. I'm like, did it save? It did. There it goes. All right, back to the problem, right? Just want to make sure I had that logged. So we put our header. What we got next? Who knows what today's title is? I turned the chat off. Let's see who can put it in the chat and tell me what it is. So what is today's title? You have to look in EDSB and find it and put it in there. And it's a 15 points if you can find it. So let me see. If you're in EDSB, we scroll down and it seems like nobody wants to tackle it. So you turn the chat off and let's just type it out, right? So basically the title is what's named in EDSB, Do Now Jamming with Rock Hero, right? So let's type it out. We already said do now, so you just put jamming with Rock Hero. Okay. We're going to center this like we always do. And we're going to come down and we now need our exit slip. I'm trying to keep everything the same that you have to do. Just got to follow along with me and do what I do, and you'll get maximum points. Classroom, term of the day, and you got to do this for the exit slip points of the day is, right, and then what else do we have to put? Our word of the day. Now, some people came early and they might have saw it, and I'm gonna trying to start it at the beginning because I've been told I got to show you guys the objective and more, but everything else I'm doing great, but the objective, right? Right here it is. So 150. All right, so now, oh, okay, who's this? Oh, welcome to class, Franklin. I gotta see if that feature is on for attendance. It is running, okay. And this nice little device to track attendance. All right, so now I think you guys can see what I'm doing. What's 11? Let's give you guys 14. Where is it? Time 12:37. Yeah, let's power through this problem, everybody, so we can have a good day or good evening. So you next need, this is what Dave was asking about, the problem. You take 1S, if you can, copy it from the chat or EDSB. I'm just going to grab that, and I'll put that here, okay? So now I have the question in there. Lee Carter, welcome to class. So come up here. I'm missing part of the question, it looks like. Grab the rest from EDSB. All I did is grab it. I didn't do nothing mysterious. Didn't do no math yet or physics. I'm just telling you directly what you should do. If you follow along, you have a great day. So I got to copy the rest. I left off with distance of, right? So it's right here. It didn't grab it. And that's also the reason why I don't like using the chat, because you guys copy and paste it, it tells. And then, you know, you get in the habit of doing that, you get yourself in trouble because people, there's a thing called plagiarism, and you don't want to be caught with that. So it drums a distance of, okay, I gotta get rid of the of part. So that's the first question. And I literally got that from EDSB. So let's grab the second part, which is your homework problem. That's your asynchronous, right? We talked about that. And while you guys are coming at me, I didn't do this. CPS brought this out. You need to do a problem with the person, kind of like the buddy system we had in college. You do a problem with a person, and then when you go home with your people, you do the problem on your own without the professor or the teacher or whomever. It's called practice. It won't stick until you actually try the problem out. So 14. So make sure you have both of these questions in there. Now I'm about to go through the steps, and there is a lot of stuff to do. That's why I was trying to like, how much are we gonna get done? So I'm just gonna go through the basics, and then we'll do the illustration last if we can. I think we should start with the illustration first, because y'all just gonna want the notes, and you're gonna put them in there. You're not gonna see anything. We're at the point where you're gonna start seeing things. So let me show you what to do. There's some diagrams you need to get maximum credit, and it also explains how this problem works. So the first diagram is what is positive work. We're going to click on insert and go to drawing. I hope you guys are inside of Google Docs and follow along, because you're going to be like, how did you do that a bunch of times? So click on new. Now we're going to make our own illustration of 3 types of works. We have work that is positive. We have work that is 0. And we also have work that is negative. So let's look at those 3 types as mathematical representations and what they mean in terms of this problem. So the first one is when you have an angle that's acute or close to 45 degrees. So we're going to grab a line, click on line if you're with me, and make a line. Once you do that, you can grab another line and connect it and make the 45-degree angle. You can connect it from here and do it like this, or you could do it reverse. Let me undo that for a second. So that line's supposed to connect. You can connect it here, for instance. And then you just want to make the angle, hold on, undo. Make the angle 45 degrees. So I click on arrow and I drag it down. And that's a 45-degree angle. This represents the type of work that is positive, right, in that direction. So if I clicked on this, I would get an arrow. Just change the type of line, right? You get an arrow like that. So this is, I'm gonna type in there the first diagram you got to make. You're gonna type a text box and label it. So what does this give you, and how will you know? Well, again, this is for positive work. Okay, and that's when you have an angle that is pretty much, well, we're not going to do the thetas and degrees because I want you to see the calculations, but it's usually 0, so -90, let's just show it out like that, degrees, 2, or sorry, less than, there we go.
I'll send you another 50. I was like, for me,
I'm sorry? Oh, okay, I was like, what was that about? And then if you're really clever, you're going to put the theta symbol in there, but don't put theta because they don't want you going through too many steps. So just put THETA. We talked about this yesterday. And then this one, and it's going to be 90 degrees, positive 90 degrees. So you should be editing your document the same way as mine's. Just grab this and bring it down. There we go. So that's the first part. Now we're going to make some more of these. So I'm just going to try to see if I can grab all this and just move it up a little bit. And then we got 2 more types of work to draw out. We have one more that's going to be what? That's our 0 work, right? Well, 0 work is pretty much anything that's 90 degrees or perpendicular. So I'm going to grab a line. And I'm going to make a perpendicular diagram. I'll grab one more. See if I can do it this way. And et voila, that is 90 degrees. All right. So if you don't understand the 90-degree part, you could just, let's put a box there so you'll see it. So if I put just a square here, Freemasonry, you see that is 90 degrees. All right, so that's one. And this is when you have what we talked about, 0 work, right? This can be anywhere from, what's the range of this? It's just theta, which is the angle. Whatever angle is pretty much equal to, or was it? No, equal to positive or negative. Positive, negative, 90 degrees. Okay. That's the first. That's the first for that one. We got one more to talk about. I hope you're drawing these out because we're about to put them into our document. We're literally simulating what is occurring in this problem. These are your initial notes, everybody. So I hope you're getting them down. Okay, so I made that too small. Let me stretch it out. There we go. Just want to move it up a little bit. Got one more to talk about, and this is when you have negative work. So what does that look like? That's anything that's going to go past 90 degrees and go around the circle like 270 degrees. Okay, now this is, I'm talking about a complete circle if you're not sure what I'm talking about. So let's keep going. For this situation, I'm going to grab a line. I hope you're following along. No, I want to click on line. There we go. It still selects this. Why? Come here, you. Okay. You're doing something different. There we go. And I'm just going to grab 2 lines, now point. And with these 2 lines, I'm going to make, let me rotate it. There we go. So, I'm grading you basically on how well you can reconstruct these diagrams. And these are usually going to be eventually be called geometric vectors, if you will. There we go. So this is more, what I was saying, more than 90 degrees. So 90 degrees would be straight up and down, right? But this is more 90 degrees, and it's going to go all the way to 270. So what is the note for this one? And this one, I forgot to put here, this is what? 0 work, in case you didn't know what I was talking about. So I'll put that there for you. This is 0 work. Okay. Time is at 12:46. We're doing good. And then I can jump into the problem. Next, you need this one here. Oh, Garcia left. Okay. It's called, like I said, it's going to be 90 degrees. And you bring it, this is the range of it. So theta, not 0, but theta. And it's going to be 270 degrees. So it rounds and goes around the circle. It stops at 270. And that will be considered just negative, straight negative work. So let's type that in. This is negative. All right, so once you're done that, now we could insert this diagram into our document. You hit save and close. And at voila, as the French would say, it'll pop up somewhere. There it is. So this is all one diagram that I can move around. To move it easily, make sure you click on the word wrap feature or wrap text. And this will allow you to drag it all over the document. So I can just, once it's clicked, I can just grab it. Like that, see? All right, so this is our first diagram. Now we can start the problem. Did everybody keep up so far? Everybody got this diagram created? This is not something I could throw in the chat. You had to be doing it with me.
Yeah.
Okay, all right, just want to make sure. So that's what you got to have in your diagram. And next part is doing the problem. So let me edit this a little bit. Those are your initial notes. Now, what else do we have? We got to talk about what we use to calculate the problem. We're talking about, in this case, total work. So a couple of notes you're going to need, right? That you may have forgotten about. Put my notes in the center. That's what I want everybody to do. And you should be typing what I'm typing to make sure you get the full credit, right? So the first thing you want to understand is you need to know that force is equal to, we talked about this previously, it's Newton's second law again, to mass times acceleration, right? We talked about how that is measured. So force is in terms of newtons, which is equal to mass in terms of kilograms, and it's multiplied by the meters per second, and that's going to be squared. Right, so let's raise that to the power of 2 real quick. There we go. And change it back. Both parentheses, all right? So far, so good. These are some of the notes I'm giving you guys. I hope you're typing it in. What else do we have here? Let's take a look. We also need to understand that friction is based upon that same calculation, right? So what you would call a lowercase f, this is what I would say is, let me just write the definition out for you guys. So frictional force is measured very similar, right? I'm trying to tell you, but it's usually in the negative direction or negative work based. Down here. And this is also mass times acceleration. All right, just wanted you to know. So with that understood, And these dimensions don't change for these two calculations. With this understood, we can now talk about work again. So I don't know if you remember the equation for work or not. Well, work is equivalent to our force, which is multiplied by distance. Okay. That equation was written out, and I forgot to put the equations for these. So the equation for this one is what? That's going to be F is equal, our math equations. And then the same is true for frictional force. It'll be just measured lowercase f, keeping it simplistic, m times a. So I can get fancy with how they did, how they document it, but just understand that's how they set it up. So we were talking about work. What is work measured in? Work is measured in joules, which is equivalent to force, which is still newtons, times distance, which is only measured in meters. Okay. Simplistic math equation for it is work, or W, is equal to force times distance. Okay. All right, so we have most of our notes. I think we're missing one thing, right? I think we're missing gravity. But let's hold off. Let's do our known and unknowns and then start solving the problem. So what do we know about the problem? And maybe I should put that in the chat so you guys can keep up, right? Second. Okay, let me come up here and grab this. The hardest part, I think, everyone, was the diagram. I was like, I gotta hurry up and do that with them, because you got to see it. It's hard for you to see it mathematically if you don't draw it out. It's called free body diagrams in physics. So does everybody see in the chat? You have to still set it up the same way, meaning your notes are centered. The next part I'm about to go through is the known and unknown values. This is my way of making sure you're paying attention and giving you every chance I can to help you pass. Do you think you need 2 minutes to catch up, or no? Because we still got a bunch of stuff to do. And these initial notes, I think they're pretty straightforward, right? Or no? You guys need 2 minutes or no?
Yeah.
Okay, who was that? Franklin? All right, so let me put the clock up. So just try to get those initial notes in your document set up, because close to the end of class, I want to do share outs for your in-class points. And we still got a lot to do. We just got done with the diagram. That was kind of tough by itself. For some people, it might have been. Oh, welcome back to Mia. There we go. All right. Okay, so let's go through the next set of notes because it's 12:55. We got to here at 1:20. We still got a little bit more to do. So if I scroll up here, you'll see that we got known and unknown values, and we take those from the problem. So let's see what the problem gave us. F, that's that force that I said was force equals mass times acceleration. They tell you is 47.5 newtons. So we're going to come down here, and we're going to put F is equal to, for force, as applied force, to, what was it again? I think 47.5. I know it's 47 something else. And that's newtons. Next, what else did they give us? Look. So it has a kinetic friction opposes the motion with the force, right? So that was what I was telling you about. That is your frictional force. And, that is what they gave us. It's going to be 28.5 newtons. So we're going to say lowercase f, 28.5 newtons. Okay. One's going to be going against it automatically. Don't get confused about that. It's friction. They also gave us mass times the gravity. You can say that's acceleration, or A. So we're going to say mass times gravity. They just give it to you in this case. It's equal to, scroll up, what was that again? It's 56.8. And this is in newtons. Okay. So now, 1 second, everybody. People to making this. Oh, goodness. Oh, Lord. Staff. All right. So mass times of gravity. And what else? They gave us one more thing, I think. And was the distance, right? So slides a drum set a distance of 1.95 meters. Now there's a diagram I would have had you do, but it's not a lot of time, where you actually draw the box as the drum set, and you slide it across the floor. You see how much friction goes one way and how much friction force goes this way. But for the sake of time, I have to just say we're going to calculate our distance, which is D equals, scroll up here, 1.95 meters, right? So far, so good. Unknown is what? What are we looking for? Well, if you were paying attention at the beginning of class, it was, let's see if I can pull it up on the screen for you. This is our objective. And this is where I'm going to take a pulse and see where students are still paying attention. In the gray box, let's see who's here. Ms. Franklin, can you read what's in the gray box that says agenda? I'm going to turn my phone on mute.
Today objective, students will be able to calculate the amount of total work with respect to force, distance, and the angle.
Thank you. Lee Carter, can you read what's in the white box? It says classroom term of the day.
Classroom term of the day, total word of the day, refute.
Thank you, sir. All right, so those are the two things you need for your exit slip, by the way. But I want you to really understand we're working to understand total work. And the objective today is the same things we've done a couple days ago and last week. Now we're going into total work from positive, negative, and zero. All right, so let's come out of this. Okay, so 12:59, I'm almost on the mark. So I'm gonna come over here. Your only unknown value is work total is, and we can call this W TOT, but you can drop this. That's the mathematical version I'm gonna use later on for you guys. So format, drop that down. And that's how that's supposed to look. Just went to Subscript in case you guys are wondering. It is equivalent to some number we're going to calculate, and it's just going to be joules. So that's too big. That's what the problem is. Let me come over here, fix that. There we go. All right. Rocking and rolling. So now our strategy, right? How do we solve this problem? Well, I told you earlier, you need basically work total. There's one more equation you can use for that.
First of all, what is we doing?
What do you mean, what is we doing? We're doing the same thing we've always done. So try to catch up there. You just got back, I think.
How? How I'm gonna catch up and you all the way down now?
Because you got to take your time and try to retype
No,
what I have on the
no,
screen.
no.
Okay, well then mute yourself, but we'll talk about it later. All right, so let's keep going. Work
Chill out, Miss
total.
Bossy.
It's okay. Should be all right. So we got to keep going though. Can't stop the whole world for one. All right, equals, so work total, solve for, I should say. And using an equation such as work total with small. Let me change that. It's the equation you're going to use. It's real simple if you understand that you got 4 works going involved. And I'll just tell you what they are. You got work 1 plus work 2. I think it's 4 altogether, right?
In the subscript.
What did you say, Franklin?
What is in the subscript?
The subscript, TOT.
Thank you.
No problem. And work 4. So you're in subscript, like she just said, very good eyesight. But your subscript is 3, 4, 2, all those, because those are subscripts. They're designations. And if you get into the workforce and you're dealing with resistors, cable lines, if you don't pay no attention to these numbers, you can hurt yourself. So you got to pay attention, and it has to be written in a certain way so other professionals know you know what you're talking about. I'm just going to subscript all these. That's how they're designated. And that's what she was asking about. So now that we have that equation, we can just go through and see what we have. Now let's think about it. We have the work of, where is it at? Here we go. We have the work of the weight, because I want to keep it simple. I thought about my notes when I wrote this out. So this is me rewriting the work total equation. But last night I was like, this is going to be a little hard for them. Copy that. Put that there. But now we're going to put in what each one means. So where are these works coming into, and how did I know they was there? So you have the work total is equal to, let's put this again, the first work is going to be what? That's the normal force, right? So work of the normal, and that's the pretty much the angle that shoots upward. So work of normal.
How you subscript?
So I'm gonna show you one more time. So I'm gonna take this one. This is the work of the weight force. So I'm gonna type in what I want. So weight, right? And it's already done, but what you could do is highlight it after you type right next to the letter, and you come up to format, text, and subscript. Okay.
All right, thank you.
No problem. So I'm just gonna subscript the rest of the terms for you guys, but there's some changes here because you have applied. That's the force that goes in the positive direction. You also have friction, if we forgot about that earlier. So now that we have those terms, we can move on. And no, not friction, it changed. Don't do that. I didn't tell you to do that, Google. Don't do that. So now, I was like, uh-oh. So now some of these terms are going to turn to 0. Because if you remember earlier, if we have anything that points 90 degrees, that's our 0 work policy or rule. Theta, which is positive and negative. So normal forces are usually up, and weight forces, they pull to gravity, are down. So that means that's 0 force for both of those works. So you end up getting an equation where you have, bring this down one. So you have for these two, they're going to become 0 joules. 0 work. Same here. Okay. And what else do you have? Well, now you got to plug in the values that you're given based upon how do you calculate work. Remember, I told you earlier, work is basically force times distance. So we can say in the first case, F, big F, because it's not the friction, times distance. And in this case, you have little f, right? Frictional force times distance. All right, I hope everybody's keeping up. We're almost through. So I think I should probably put this in the chat for you guys too, right? So let me grab that. So known and unknown and not down to this point, and then I'm gonna keep plugging it in until we're finished with it. So here we go. I'm not sure we're gonna have time for share outs because of this problem. Okay, so there's your next steps. Again, you're gonna have to edit like me because things are gonna cross out and become things. So what's next? Well, let me come here and align that. Come down and I now know what I need to know from above, but don't forget this is negative. So change that. That's going to be frictional force. I told you it's opposite. It says it in the problem. Kinetic friction opposes the motion with the force of friction, right? And that's basically your frictional force. So that's why that minus sign goes there. So let me just show you a new line and then you'll see what you have to change. So in case that's confusing. So inside of here, basically put a negative sign, which you understand because the frictional force is what turns that negative. Then the next step, it becomes this. Okay. That's for clarity. So now I can put the values in because I have force and I have distance, I think, right? Let's come up here. It says, you know, what is our mass times gravity is our acceleration. And it's also, no, mass times gravity is our, not acceleration, is our force. It's in newtons. So that's one thing we could use. Then we have to also look at exactly the distance. So we got two types we have to use. One is the force of 47.5 newtons. Then you have 28.5. This is known as weight, right? You don't use that. You come down here to plug in your values. Take this, come down one. And what do we do? So force is the big F, right? Go to our notes, that's 47. That's where I'm getting it from, everybody. 0.5 newtons. Distance was, what was that? Let's look up top. It's 1.95 meters, right? And what is this going to be? It should be very obvious. Just come up there and look. It's 28.5 newtons. The distance stays the same. It's 1.95 meters. Okay. I'm literally giving you all the steps you need. So now some things are going to cross out, right? Of course, this situation is going to get better because I should have crossed out the joules a long time ago. Just leave it there so you guys don't have to redo any notes. I'll start crossing out this point, though. So let's copy this. And let's come down one. Cool. Now, this is gone. Let's just start crossing things. That's why I was waiting to cross everything out. This is gone, right? And then what else is gone? Well, you know, newtons and meters, they make work. So at the end of that, you're going to get joules. So these are gone. Because they're going to make joules. That's what newtons, force times distance, right? They still multiply, though, the numbers. And then the same thing happens with these two. Okay, almost through. And then we'll just worry about share outs tomorrow because it looks, I really want to see who else to get their points today, but I'm not sure how much y'all got done. Let's clean the equation up. So basically at the end of this, it'll be joules. And then at the end of that one, it'll be joules too because it crossed out. So the new equation will look like this, right? Take some things out. And take these out. There we go, that's better. You see it just gets smaller. It's almost time, I know. Almost at the final answer, everybody. And this is gone too. Okay, so that is your final calculation. What does that look like, right? How do I put that in the calculator, Mr. Tyler? Here's how. Let's just say we're gonna leave one of these joules here and then say, all right, let's put it in Math Papa to finalize it. Overall, I'm saying this whole thing is gonna be joules once you're done with it. All right, so how do we calculate that? Real quickly, if we go to our Math Papa, and you have to type this in and get the final answer, scroll up. And before I do that, let me put this in the chat because you guys need that, right? Just make sure you edit it the same way. Okay, let's see if it fits though. Let's see if it cuts anything off. I think it did. Let me see here. What are joules? No, I didn't. I think you got everything. Yeah. So you just got to calculate the final answer, which is this. It's going to be just WTOT for work total, right? Is equal to some number in joules once you're done with it. To do that, like I said, here's Math Papa, because we're about out of time, everybody. And I want to see if anybody wants to share out so I can give you in-class points. You don't have to have everything I got done, but you should have all these notes by 8 p.m. tonight with the videos and the transcripts because they'll be available. What I do is I load also everything we've done in the chat, so you guys have everything you need to achieve success. So no excuses. All right, let me see. I see cameras off. Who's in class today? So Franklin, are you there? Lee Carter, where your cameras at? Stevenson, Tamia.
Well,
Okay, what happened to your camera? I'm sitting there doing a problem. Y'all got your cameras on.
oh,
You on your phone? Okay. Did you get anything done so far?
yes.
Okay. Can you share like how far you gotten?
I'm on the same. I'm on the end. Like at the end.
You on the last steps and stuff?
Yeah.
Oh, okay. I just want to see what you've done so far because you're about to run out of time. Oh, okay. It's not on. Let me see here. Oh, I turned it off. I'm sorry. Let me stop presenting too, because sometimes that holds y'all up. All right, can you try it now? I had it off. I didn't even know. Well,
on my phone.
you on your cell phone?
Yes.
Oh, so is it hard to share?
Yeah, I don't know how to share on it.
Oh, okay. All right. Well, you want to share your share out tomorrow?
Yeah.
Okay. Just make sure you finish the other problem the same way. Change the numbers. The homework problem is due by 8. You're free to leave if that's all. You can try to get your points back tomorrow. Who else I haven't called on? Stevenson, what about you? Was you able to get anything done? Oh, I don't see him. He left. David, what about you? Do you have anything you can share? Did you at least get started on a document?
Yeah.
Okay, can I take a look at what you did? Amir left. They don't want to share their screens.
Yeah.
Go ahead and share your screen, sir. There you go. Okay. Oh, you did the diagram and everything, dude. Cool. Okay. You're keeping up. Where'd it go? Okay, you started working on the second one too. Okay. Now make sure you change those numbers. They're not exactly the same, right? Your frictional force there is For 2A, you're doing good. For 2A, it's actually, you see how it changes? It's 29.4 there. So you're going to change that little f, right, in your knowns. It's not 47.5. So just take your time, but you're close. Good way to start. All right, you can stop sharing. You got all your points. Pretty good. You keeping up. Who's next? I got Lee Carter. You're free to go too, Mr. Concepcion. Just turn it in by 8 p.m. tonight into Edsby, okay?
All right.
Lee Carter left. Why did he leave? They got they got to share this work now. I'm trying not to hurt no people's scores. To me, did you catch up? Did you start anything?
No.
You're having a bad day today, huh? All right, we'll try to get something turned in by 8 p.m. tonight, dear.
I'll think about it.
Okay, you have a better day. Ooh-wee.